All right, this is the Service APIs meeting for May 21, and we've got a lot to talk about today. As always, anyone can feel free to add things to the agenda. I tried to scope out some things that I thought were worth covering in more detail, but feel free to add things to any agenda just so we make sure we cover what's most important. First off, I wanted to talk about multi-cluster traffic splitting. This has been a doc that's been around and circulating a bit just through comments on issues. But before I took it any further, I wanted to discuss it here, just in a broader setting, and make sure that this proposal actually made sense from the perspective of everyone working on these service APIs spec, and then we can try to share it beyond this group and get additional feedback. So with that, I'll move over to this multi-cluster traffic splitting doc. And without going too much further, Jeremy is on this call, and he is responsible for this excellent KEP that I've referenced here that defines the multi-cluster services API. So thank you to Jeremy for making this a reality. And I think, Jeremy, what is the status of this? Is this, are there still a couple changes that that need to get in, or is it basically final at this point?
So I think the things that are in here are pretty final. There's a couple remaining changes that I need to push up to kind of fill this out a little bit more. You know, some of the bookkeeping, like graduation criteria and how we're going to test it, things like that. The decisions about Q-proxy that at the last Signet meeting, for example, too. But I think the stuff that's here is pretty representative of what's going to happen. I think there's a few more things that need to get spelled out, like how we're going to handle headless services. That's not really defined yet. I think in here it's still a to decide, but I think we came to some good ideas there. So I've got a couple PRs to go up, but I think this is a good starting point.
Okay, great, thanks. And so, yeah, I'll walk through the basis of this doc, and really my scope here was trying to ensure that traffic splitting as it's already proposed for service APIs was compatible with multi-cluster traffic splitting. So in this case, traffic splitting is in the context of splitting traffic between different services or other similar resources. And my theory is that this can apply equally well to multi-cluster resources, whether it be service imports or service exports or whatever it might be. Configuring the proportion of traffic routed to each cluster is part of a multi-cluster service and can be solved with the multi-cluster API. That is kind of the key thing here, that in my mind, as part of this proposal, multi-cluster traffic splitting has two layers. There is multi-cluster configuration of how any service distributes traffic between different clusters. And there's our traffic splitting on top of that that is more app focused, that would then indicate application versions or different forms of configuration, or Canary beta, those kinds of differences. And I think one thing that has to be explored anytime you look at traffic splitting is, what is your lowest level? What is that lowest unit, the atomic unit that is the bottom of your traffic splitting design? And I looked at and explored the possibility of adding some kind of layer below service that might include a new field on service that would allow you to say, okay, that this service should have endpoint slices that are split on unique values of this version label, as an idea. So then you can target endpoint slices that have for the same service that have version 1 or version 2, etc. This seemed great on the surface, but unfortunately has a number of negatives. It would it require extending the already complex service resource, which is not a small task. Endpoints themselves would not really have a great path to support subsetting, so this would be dependent on endpoint slices. And adding any kind of subsetting API to services without any corresponding traffic splitting implementation might feel out of place. So if you add some component of traffic splitting to services, but don't have any way to do anything with that, it may feel a little bit strange. And traffic splitting, you know, it would be nice if it could support L7 concepts, like header-based splitting, which is just never going to be compatible at a service level. So defining traffic splitting in both route and service, I think would also be confusing. So I thought that it would make sense to avoid going down this rabbit hole and considering that service was the smallest resource there is. So if you have multiple versions of an app that you want to split traffic between, you would use multiple services. And feel free at any point during this to stop me if you have any questions, comments, thoughts, whatever.
So I have a question or comment from Istio coming.
Yeah.
In reality, most people split the traffic between a Canary and a production or something, and the Canary can be deployed in 5 clusters, production another 3 clusters. The structure of the API is a bit difficult to express this kind of stuff because I want 5% to go to Canary regardless of what cluster it is, and 95% to go to production.
Yeah.
This seems to be more oriented about splitting between clusters, not splitting between subsets, where subsets are spanning multiple clusters. And I
so
think that's problematic.
No, I get that, and I think that's more that I have not explained this well enough yet. But that is very much a goal here, to be able to split among different versions, Canary and production, as an example.
Okay. I think, Rob, you might want to preface that this is exploration, but this is not the proposal.
Yeah, that's fair. Yeah. Okay, so we'll keep on going here. The initial idea was that we could use traffic splitting weights that are defined globally as part of routes. This is already, you can already see an example of this in a PR that Damian had raised. This is basically exploring if that approach works with multi-cluster resources. So each split can target any variation of service or service import, and after traffic splitting, traffic will be routed to each service with the same logic as any request to any other multi-cluster service. So based on proximity and cluster capacity. So let's jump down a little bit. I'll cover this a little bit later, but I think it would be helpful to get into an actual concrete example, just to specifically answer, I think it was Costin's question about Canary deployments and how that might be modeled. So in this example, let's say 5% of traffic will be consistently sent to Canary endpoints, while the remaining 95% of traffic will be sent to prod endpoints. So organizations are sending a consistent percentage of traffic to a specific service, and it doesn't matter what clusters either service is deployed in. A fixed 5% of traffic would go to Canary, and a fixed 95% of traffic would go to prod in this example. And I also get into a little bit of how a rollout could work here, where you gradually upgrade from Canary in one cluster to, you graduate that to prod, but let's say V2 is in Canary, and you make V2 prod in cluster 1, and then you gradually work that over. So an increasing amount of your prod traffic is actually seeing V2 as you do this cluster by cluster rollout.
Sorry, that was really my question. I mean, because in reality, people don't do that. People just do in one cluster, they have both prod and Canary.
Right. And so, yes, and in that case, this works just fine, but you're targeting two multi-cluster services, and those services are entirely independent of each other.
Right. So
Yeah, if you
I
could,
guess
if you could
Rob
put an example.
Sorry, Costin.
No, just if you can express this example, because that's the most common use case, like Knative is doing. Say shift one particular workload in one cluster. Yes, there could be two clusters, but
Right.
Rob,
So
would
in,
this be independent then? Like the Canary service could be in separate clusters or the same clusters or both. You know, it
yeah,
doesn't really matter.
exactly that. Exactly that. So you can. It doesn't really matter. It just happens to be wherever Canary is deployed. And if you happen to have Canary and prod in every single cluster, that works. If you have Canary in two clusters and prod in all your other clusters, that works too.
So I think
Does that
like it
help?
might be worthwhile to go into, because some people might not be familiar with the overall like way the multi-cluster stuff is proposed to be organized, which is basically that this service import and the name of that service is going to be a cross-cluster concept. That app1 Canary refers to actually several, you know, services that are distributed across different clusters. I think Jeremy, maybe just like a couple sentences to give some
Yeah.
context, because
Yeah.
people who don't know about it would not quite understand what's going on here.
Right. Yeah. So a little bit of background there. Basically, a service import is a multi-cluster abstraction over services that exist in other clusters. So the basic API is you create a service export to say that you want a service to be visible to the clusters in your group, and that creates a service import in each importing cluster that represents that service. But the backends might be in any number of other clusters, or they might be in the same cluster you're in. But accessing the service through the service import is basically a statement that you don't really care where the backends are. Does that help?
Yeah.
Cool.
Yeah, that's helpful. Thanks.
Rob, can you go back down to that example?
Sure. I think this actually matches your PR pretty closely, if not exactly, Damien.
Yeah, and I'm just trying to make sure I understand what I'm seeing here. So what I see in this example is two service imports that we're forwarding. A request comes in to this cluster. We match this HTTP route. Gateway matches for HTTP route. It's for foo.com and the route path, and we're saying send 5% of the traffic to service import Canary, and that service import specifies a service that has been imported from a different cluster. Is that correct?
It could be any number of clusters, but it is a multi-cluster service.
Right. I guess the point I'm trying to make is it's not a service. It's not a service resource in this cluster. The service import is representing a service that is a service resource in some other cluster or clusters. Is that correct?
Right. Yeah, that's correct.
Okay.
But what you said earlier is that service import may also include the local cluster. So service import is effectively a replacement for service.
Yeah.
Okay.
I guess that works.
And let's say Canary was in this cluster. The way that we've designed for two is we could say, oh, you know, I only need to use the service import for prod because that is in some other cluster, and I could have represent a service. The app1 Canary could be just a standard service resource instead of a service import resource if Canary was locally running locally in this cluster, right?
Yeah, that's a great point. You could mix the kind of resources you're referencing to reference a local Canary and a global prod deployment for servers.
Yeah, and I need to look at the CAP. I know I've reviewed the GDoc, but I need to look at the CAP. But all right, I just wanted to make sure I understood what I was saying. Thank you.
Same here, I want to understand. So to be clear, service, import and service are effectively equivalent, can be used in all situations. One means local, the other one means aggregate. Is it correct?
Right.
Okay, perfect.
Yes.
Then it's perfect. Yeah, great.
Great. All right, and well, I'll back up a second. And we've generally already covered this, but in the multi-cluster model, as I understand it, there will be a config cluster that contains configuration that can apply globally. And in this proposal, I'm suggesting that gateways and routes could live in this cluster, and then they would reference service imports or other such things that were in each individual cluster. There's no hard and fast rule it has to work that way, but that is a way it could work. And Jeremy, you're welcome to chime in if that makes sense or doesn't make sense.
Yeah, I think that does make sense. From the multi-cluster services definition standpoint, we've been trying really hard not to define anything like that. There has to be a config cluster or centralized model, or an implementation could be free to be decentralized. But this absolutely would work. This fits the model. I think we haven't made the assumption that there is in fact a config cluster.
Okay.
But we've also made sure that there absolutely could be a config cluster.
Yeah.
Yeah, I think the thing to highlight is not that there's a single config cluster. It's that right now when we're designing the APIs, we do not expect to solve the problem of, for example, having people define things in multiple places and somehow merging it automatically. At least right now, like that seems like a super hard problem to do, at least at the service API level.
Yeah.
So this creates a hard dependency between the traffic split HTTP route and the multi-cluster API, effectively.
I wouldn't say it's
all
a
in the family,
dependency.
Costin. It's all in the family.
Yeah.
I know.
Yeah, I'd say they can both work independently, but they should also work nicely together. They should be compatible.
Yes.
No, I ask you because if Istio is implementing this, and obviously all our services are multi-cluster by default, so we'll effectively need to implement service import as well to keep the existing behavior. But that's fine.
Right.
I think it's reasonable.
Right.
I mean, you might get it for free. Talk to Jeremy.
All right, and I'll move on to what this could look like for L4. And in theory, this is really the same thing, just with TCP route. And admittedly, this is a very theoretical TCP route. We don't actually have a TCP route defined. So this is just theoretical, showing how this could work. Obviously, there's not really a way to accomplish L4 traffic splitting without some kind of route concept in this model. So this is showing what a route could look like that involved traffic splitting for L4 protocols, which is very similar.
Yeah, I think the thing to note here is that because we have a TCP route, we can have a notion that it's going to be like per connection, or like, define it more specifically. And then the other thing to note is, like, right now we have provisionally this weight, which we haven't defined very carefully. That's going to be a further discussion as to what exactly actually that means. But, for illustration purposes, there's some kind of configuration that's going to tell the system how much traffic to send to each place.
Yeah.
If I can make a request, it will always be useful to speak about TCP to also include TLS, because again, very few people are using TCP, hopefully, those days. So examples with TLS are very useful. And I assume since you have host name, you imply that it's also work for SNI routing and TLS. So it's wonderful.
Yeah. And the other key thing here, that this is really, I hate to say a shot in the dark, but it's really tentative. This is an idea of how this multi-cluster traffic distribution could work. And keep in mind with this whole doc, I'm really saying this is not really the scope of service APIs to define this, but I just wanted to show potential ways these two levels could work together. So as an example, this is likely not going to happen the way I have it spec'd out right now. You could have something like a max rate annotation or field on either service or service import that further specifies the amount of traffic that should go to a specific cluster. In this case, it would be the maximum number of requests, or maximum number of connections is another common way to do this. The most difficult thing here is finding a combination of fields or values we can base this off of that enough implementations could actually support. And max rate seemed like a relatively well-supported one, but it doesn't give us everything we might want. But one of the key things we want to be able to do is still have a service represented in a cluster with its pods and everything else, but turn down all traffic to it, or gradually phase out traffic to it, or gradually phase in traffic to a specific cluster. And something like max rate at least allows us to do that. Though I am very, very open to other ideas for how we would configure this for multi-cluster traffic distribution. And frankly, this may be a little out of scope for service APIs. I don't know, Jeremy, you're the multi-cluster person. Do you have any thoughts on this one?
Yeah, I think, so like our initial data plane for multi-cluster services is kubeproxy. So like that would be harder to express, but this definitely seems like it maybe is more of a multi-cluster service thing. Like I think this needs to evolve with service APIs, but maybe the right place for this, because this doesn't really make sense in a single cluster context, would be the service export, which is that resource that you define to denote that a service should be public. Like that seems like a reasonable level for this kind of this property. Like this property only has meaning in multi-cluster, but it also only reflects state of the local clusters backends. If that makes sense.
Yeah, the other thing that Harry, sorry, did I cut someone off?
No, keep going.
So Harry put up an issue where basically we're talking about how to extend service kind of on the side with respect to various properties of service. I remember like health checking and all that stuff. So this may be something else that's also relevant there.
I want to say it actually does make a lot of sense in single cluster, especially if it's defined as max rate per endpoint, because circuit breakers and how to allocate to load balance, it's super important in.
That's true.
So it will be super useful to add it in, and it will map to our API as well.
Right. So yeah, if this is a max rate per endpoint, then it has more.
Then it will be wonderful yeah.
Cool. Well, and always feel free to, or please comment on this doc with other ideas. I see, Costin, you added a comment here. That's very helpful. Yeah, I think max rate per endpoint would be very useful. But again, like Jeremy alluded to, it's hard to add attributes to service that kubeproxy can't support. But maybe we have to start. Yeah, I'm not sure.
And I'm trying to understand how max rate would work with weight of a forward to target for a route. Because right now we have, right now we've got that forward to target, and the PR that's out there is basically saying, okay, we can apply weights to each individual target, with a target, let's say, being a service. And so my understanding with the kind of the using weights was that if we said, okay, for this target, I want to quote unquote take it out of service, let me change the weight for this target to 0, so we stop forwarding requests to that service.
Yeah, this definitely gets tricky without the multi-cluster component added in. The idea I had been thinking, or the way I'd been thinking about this, is that max rate would be a multi-cluster concept, which, as it turns out, it could apply beyond multi-cluster, but it would be informative when you target a service import, kind of a global service. If max rate is already accounted for in a specific cluster, then you waterfall over to another cluster that still has capacity.
Or another endpoint.
Yeah, Dania, this is a very complicated thing, because I think the example that, just to put it out there, that is interesting is if you have Canary and non-Canary, and the Canary completely dies, if you're sitting 5% there, probably you don't want to be black hole? Question mark. So that's one example that we're sort of playing with to see if we can do it right.
Well, I'm not sure about that, but yeah, it's a good question.
Yeah, the meaning of 0 is easy, because like 0 times anything is 0, but the meaning of
Right.
anything above 0 is complicated.
Yeah,
Right.
yeah, and yeah, this is really getting into territory where it seems like every implementation I've looked at supports different things, and there's relatively little overlap between them. So
May
okay,
overlap
well,
with horizontal pod autoscalers and other specifications, because that's also something that hopefully the autoscalers take into account, or could take into account. Meaning, if you specify max rate 100 and you have all of them are busy, you start new instances.
yeah,
Right.
yeah, makes sense. And then just as going back to a very simple example without any traffic splitting, this is just an example of how you would target a multi-cluster service directly without any form of weighting or additional traffic splitting. Really simple, really straightforward. Looks very similar, just without any traffic splitting. And finally, there was an idea of a full Canary cluster that I thought was worth exploring here. And that the idea here is that some organizations choose to replace entire clusters instead of doing in-place upgrades, as an example. And so, a Canary cluster or set of clusters receiving a portion of traffic and then gradually shifting that traffic over and over to your new cluster. So maybe Canary cluster isn't the appropriate term, but whatever it is, maybe blue-green. There are a few different models that could work here. In this full trust model, you deploy the same service to the new cluster and immediately opt in. That seems risky, but it is an option to spin up a new cluster. A medium trust model would involve deploying the same service to a new cluster with a max rate of 0, or whatever that field is, and slowly increase that to full capacity. And the low trust model would be treat the new cluster as new services, new service version, new everything, and follow service APIs, traffic splitting as defined with weight. So those are a few different ways you could use the various levers we have available in this proposal or exploration. Do any of those make sense?
I think these are excellent use cases to run through for sure.
Okay. Okay. Cool. And that's that is the end of this exploration. I did look into a variety, and I did not do Istio justice. So sorry to the Istio folks on the call. Yes, so John or Costin, do you want to cover a little bit more about how Istio does traffic splitting?
Yeah, so there's kind of two modes. One, we allow people to say like 20% of traffic goes to this region and 80% goes to this region. And I say region because this is actually based on the topology, not clusters. We'll probably add clusters later, but for now, that's how it works. But I don't really know anyone uses this, so it's not necessarily an example of what to do. When most people are using our cross-locality stuff, it's more about failover, so and we don't have, like, yeah, we don't, it's kind of different from here.
Okay.
Meaning most customers are asking for how to split traffic across regions, across and fallback and this kind of stuff. Nobody so far was concerned about the particular cluster.
Yeah, that makes sense. All right, well, I've taken up a lot of time with this. There is a doc that's linked in the agenda. There's a corresponding PR. There's a lot more that could be said here or done here. Any last thoughts as part of this conversation? Okay, well, great.
I think
Thank
just
you
generally
to,
it'd be nice to have just kind of that foundation of the multi-cluster ket that merged. So I need to again go back, look at that, and
yeah,
this
I
is
have
something
linked
that,
to that.
say if this is something that's important to our work, maybe it makes sense for Jeremy to at some point give us a background on multi-cluster.
Yeah, and if you have any questions, reach out on Slack. I'm Jeremy OT.
Yeah, we'll do.
Yeah, that's great. Okay, well, I think we just have 10 or so minutes left. Well, real quickly, I will go ahead and reference Damien's PR that, as far as I recall, is basically a copy. Well, that doc was based on this PR. So this is also a place that we can comment and discuss this this doc and this approach. And then James, I don't think he's here yet. He may not make it, so I'll leave this. I know we've discussed this recently, but he has a really interesting PR that moves listeners around a bit and notably moves routes to be per listener instead of per gateway. I think this is widely popular PR, but and it has received some recent updates. So just encourage everyone to take another look at it. And then the last thing I wanted to cover is actually an issue raised by John that I think is really interesting. And I've filed a couple PRs that help here, but they're incomplete. And so maybe, John, do you want to give a bit of background on the issue and complexities here?
Yeah, so I think there's two parts. One is that we have this route selector that it doesn't have any type, right? It's just selecting labels. And since we can have all sorts of different routes, like HTTP route, TCP route, maybe vendor-specific ones, that's kind of confusing, especially if we talk about portability. Like if you assume that you have your label selector foo equals bar, and it's selecting HTTP routes and TCP routes, and then say you switch to Istio as an example, and you have some virtual service with those labels, all of a sudden those are going to start being used when you really have no idea. So you get this weird behavior. And I don't think there's anything else that's doing label selection across multiple different types in Kubernetes. So it's kind of setting a new precedence, which I personally, I don't find it that useful. I think it's more useful to be explicit and just say, like, add like the kind there or something. So we say HTTP routes match this label, TCP routes match this label, something like that.
Yeah, we actually had the same note in the doc on layer 4. Adding TCP route made this kind of confusing with HTTP route. Maybe a kind makes sense.
Yeah, so we had a discussion about this yesterday. Sorry, I'm cutting someone off. But also, John, could you file 2 issues? Seems like 2 issues here. So if you go down to the bottom. Yeah, so we discussed adding kind, and that seems to totally make sense. There was some additional talk about what that would specifically look like. I didn't hear many people on the call actually not want to do this. So this might just be a nit that can be fixed.
Yeah, I think that as I recall, the consensus was that we should do this and that we should start with support for a single kind. And if there really is a use case for multiple kinds, we could eventually transition to a list if it was necessary. But I think in most cases, we will be fine with targeting a single kind.
The second problem is probably more important for security purpose.
Which second?
The namespace.
Yeah, the namespace.
The namespace thing.
Okay. Yeah.
If you could scroll back up, I forget what I was saying originally.
Yeah.
Oh yeah, so the namespace stuff is entirely based on like the conclusion that only cluster admins have namespace label permission.
Yeah.
Which it may be the case for some people. I don't know if it's the case for everyone. I would assume that even if it's the majority, like we can't. It seems like a strong assumption to make without more evidence that that's the case in all deployments, because basically my concern would be that if you just want to have routes within your same namespace as a gateway, which seems to be a fairly common case, there's actually no way to do that if you don't have this enforcement, because you can add like some label name equals foo, and you're in the foo namespace, but someone else can add that to their label to their namespace as well. So yeah, I mean, it makes sense in some cases, but at the very least, it would make sense to have like selecting by name or something that's actually unique. I saw you had that PR for adding like only local routes or some similar field, which makes sense. I don't know if we need more flexibility or not. I really don't know what most people are doing around this. It just felt like the current approach may not support everything, but I'm not sure what the ideal approach actually is.
Yeah, no, it's a great points. And I know our idea of using namespace, we definitely went back and forth between a list of just namespace names versus namespace labels. There may have been other things that that ended up deciding this, but I think a key one was that network policy already relies heavily on namespace labeling. And so this would not be the only thing where your security would be compromised if you allow just anyone to label namespaces. So there is precedence there. Go ahead, Costa. Or go ahead.
I would say this is not entirely a good thing, saying that, hey, that other one is broken, we can be broken as well. I mean, it's and for I think network policies, there might be other ways around and other ways to enforce stuff. I don't know.
Yeah,
I suspect they have the same problem.
Yeah, there are a variety of label selectors at play there, and yeah, and I did add some PRs that may or may not address this. I'll go through the gateway class one because it seems most relevant right now. We had this concept of basically a 3-tier gateway class selector, namespace selector here, where nil meant only local namespace and empty meant all namespaces, and anything specified was just a regular query. That kind of matches with the selector definition, where nil is supposed to mean nothing, and we interpreted that as only local. But it was confusing, and it's very, very difficult to differentiate between nil and empty, at least as an end user. So the idea was to go ahead and add a only local routes Boolean to replace the nil behavior, and make it kind of exclusive with the allowed route namespaces selector. This partially covers it, though it is still very much a route selector, a selector for the allowed route namespaces. And the only thing it helps is the use case of the local namespace, which I think is a very significant one. But I am open to additional feedback.
Yeah, I think this might be, I don't know which sig auth maybe. I just wonder like who would own the namespace permissions recommendations problem, because we can come up with something here and then clearly now policy was doing something, but it sounds like Austin, maybe other people are doing other things. It would be good. I'm pretty sure there are other resources, not just networking related, that have this need. Like Rob, should we sort of poke around to see which other sig, which sig owns namespaces? Maybe sig arch.
That is a good question. I know we'd. It does seem like a question that would be good for SIG-auth. When we initially came up with our security model, we ran it by Jordan, and he had good feedback. And I remember at the time it all seemed reasonable, but it's probably worth running this by again, broader SIG-auth audience, and specifically about namespace selectors, because I agree that a namespace list could accomplish a similar thing. It just has other trade-offs, especially if you're wanting to target a long list of namespaces or wanting to add namespaces on the fly, which again is part of the security counter argument. But
one thing it would help as well with the namespace list is if you are a controller for some gateway class that has access to, namespace A and B, then your controller actually only needs access to those namespaces. But otherwise, I guess listing namespaces isn't that high privilege, maybe, so it's not a big deal.
Yeah, but it does. I mean, for controller implementation, anytime we're adding a selector like this, it means you have to watch namespaces as opposed to a namespace list where you don't. And that is a significant change. Yeah, so namespace list does seem simpler to implement. It just may not be. I'm not sure which is more user-friendly or more secure.
And more efficient from many ways, because you can have a low privilege gateways that it's, you may have permissions, RBAC permissions to watch stuff only in specific namespaces. So I don't know, multi-tenant or more isolations, there are all kind of benefits to not watch everything in all namespaces. I wanted to add that one trick that we typically use in Istio is to define some magic labels, both on workloads and a lot of other things. So basically you could define that label underscore namespace or whatever is reserved, and will match only the namespace of the label. Actually the same thing for cluster and a lot of other things. Network, we use all kind of things that are magic labels.
Yeah, actually that's a good point. Can you, with RBAC today, can you say that you can list, like if you say that you can only, I guess never mind. I was thinking that you wouldn't be able to do it with restricted RBAC permissions, but I guess you list the namespaces and then you find the labels that are permitted, and then you should have RBAC permission in those namespaces, and then you list all the routes in that namespace. So I guess that makes sense.
Yeah, but if you accidentally list one namespace that you don't have permissions, you'll have all kinds of exceptions and pain.
Yeah. Okay, well, I can take an action item out of this to follow up with SIGAUT. I'm not sure. I know they meet on Thursdays, but I'm not sure if it's every other week. I don't know which week it is, but I may just send something out to their mailing list too. But I will get back to everyone on this as far as what is recommended. And also, if it sounds like there's significant opinions here. I think Costin and John, you both commented. If anyone else has thoughts on this, if you can add a comment to the issue, that would be super helpful.
Yeah, it had a big impact on Istio. We had some security issues around this and long discussions how to fix it. And so it was a big problem for us.
Okay, good to know. Do you have any issues that we could link to, just reference issues or discussion around what those security issues were?
I can take a look. I think Contour and the current documentation explains how things should work. But yeah, I'll try to find out the original.
Okay, thanks. All right, well, I think we are over time for today. Did anyone have any last thoughts or comments that we should discuss here?
Have a good long weekend for those of you in the US. Also,
Yes.
Too bad James wasn't able to make it. So I guess we'll push that to the next session.
Yeah. All right, well, thanks everyone. It's been great, and have a great weekend. Great long weekend for whoever gets one.
You too.
All right, see you.
Thanks.